Okay, hello everybody. Cats and dogs, boys and girls, trees and flowers, whoever's tuning in, welcome. I'm going to translate some code here from some example code that I found in a book that I'm studying on AI, yes, artificial intelligence. David Borg and Glenn Seaman. It's an O'Reilly book. Anyways, I'm going to convert this here really quick to a function that we can use. So what we want to do is, see, there's this. I think I can just put it down here. I can just go like this. So what we don't want is GL float angle, that's fine, and it's gonna receive a vector 3. We'll call it u. I can do that. So far, so good. You know, I haven't really. Right. What are we doing here? GL float xy. That's good. I get that. Okay. X is equal to u dot x times the cosine. It's already in radians, so minus angle, is that gonna work? Okay, plus u dot y times the sine of minus angle. Alright, that's gonna work. That's fine, it's fine, everything's fine, don't worry about it. Don't worry about it. Times the sine of minus angle plus u dot y. You know, stealing code, translating code is pretty easy. Oh, and then we have to go GLM vector 3. We'll call it RV. The return vector is equal to GLM vector 3. Excuse me. So we just want xy 0.0 and then return RV. Okay. Alright, I don't make a lot of functions. I mean, outside of, that return, and this is good. This is what classes should do, and I don't do that near as often as I should. So rotate 2D. Now we have our own rotate 2D. Does it work? Does it work? Rotate 2D. Okay. So the next thing is his distance, so W, okay, which is, wait, that's another vector. Alright. What's W? I don't know. W, let's call it W dist. W dist, because I have no idea what it really. And V rotate 2D. It already knows the function. That's pretty awesome. Do I have to declare? I think, wait, because it's declared inside here. Do I need to create a function declaration? I believe I do. Excuse me. Pardon me. And I have to do it in here. I have to do it up here. Does that work? Is everybody happy? Okay, I think that'll compile then after it figures that out. And after, right? Okay, and back up to here now. Okay. We now pause our regularly scheduled program. Negative. What is it? What is the sub I? Whoops. I dot F orientation. I even use the same variable there. Okay. Comma distance. Okay, okay, that's it. So now, cool. So then what we do for the next line, actually, so that's, what is that? Is that a boolean? And I think it's used later, so maybe we should just declare it outside. All of a sudden, we're going into actual code here. In view, I'm coding, I'm not just... So in other words, I haven't had success yet, I'm just recording as I'm coding. So in view is going to equal w dot y greater than 0. Oops. We need parenthetics. Oh, w dot dist, or w dist. We may not need the parenthetics, but we need that. Okay, in view equals that. So if w.dist or w.dist pardon me dot y is greater than 0, then it's in it's in front of the okay. Radius factor. I don't think we're going to use that. I'm just reading this from a book, but what I'm actually reading is not there. It's from a book. Where's the do unit AI? Calc loads. Update body Euler. Oh, I hate that function. I hate it. I hate it. Oh. Oh, here it is. Do unit AI. Okay, and so all this stuff in here. Yeah, actually, let's just keep going here. In view and interceptor, we're not going to worry about that. Okay, so here's the next part. If d dot magnitude is less than or equal to the length. Okay, so this is just, we want to calculate d magnitude is less than a certain amount. So let's just do, then it adds to these variables. That's just the average position, average velocity, and then the number to divide those by. Okay, that's great. Here, hold on. We will come up with our own translation as we steal the code. Okay, so right in here. Okay, so we're going to go, okay, and stuff, okay. And now the translation. If distance dot magnitude. Oh, I have to make another function, don't I? You know what? That'd be cool. Hold on. Because this one uses this mymath thing in here. I bet you it uses the, there's a function. Ba-ba-ba-ba-ba-boom. It's the magnitude of the vector, and it's right here. Oh, it's just the distance function. Cool. Well, I'm going to steal and make another function because that other one worked out so well and everything, and I just like this. It's cool. Okay, so there's the function we're going to translate. Steal. Excuse me. Let's just call it v magnitude. And what do we need in order to get the magnitude? Actually, it's not going to return a vector 3. It's going to return a float. And it's going to take a vector 3, and we'll call it t vector. Oh. It's the t vector, is it? Oh, okay. So just return, okay, GL float, just like what they do in the thing here. Return GL float square root of t vector dot x times t vector dot x plus t. Okay, so let's change this from t vector to tv, because I like tv better than t vector. Changing it, called it. Okay, sorry, I'm super silly. I'm over caffeinated. You just have to deal with it and watch the video. I think that'll work. So return square root float. Okay, and the inline float vector. Thank you. That was great. But that was part of a class thing. Okay, whatever. We don't need a vector class. We already have a vector. In fact, you know what? GLM probably has a magnitude function that I could have used rather than making my own thing here. But let's face it, I need to practice. So, pardon me. That was disgusting. Right in the microphone. Okay, magnitude. Magnitude, if I could spell it. Magnitude of distance. Okay. Is it not? Did I not capitalize it, or what did I do? Okay. Oh, it's called V magnitude, isn't it? Alright, I didn't even have to look. I remembered. Remember. No. Alright, I'm silly. Okay, it's less than 0.1 f. That's good enough. You know, it's fine. That's fine. Okay, so now we have to keep track of, because if it's within range, right? And it's in view. So it's in view. If magnitude, wait, is that how it works? Where is it? Where did I go? What did I do? What is happening? I entered an alternate reality. Wait, that's calc loads. and there's update body Euler. Wait, did I miss it again? I changed. Okay, we're in here. So if in view, so that's what I forgot to put. I was like, why is it going to do that? So if in view and magnitude distance is less than that. There you go. There you go. Okay. So now we need what? Another vector, and an integer. Okay. So let's just go p av, comma v av, and then an integer. Let's go GLU int. Let's call it, you could call it capital N if you insist. Okay. So now we're just going to go units JV, and this actually works. My translation was so good, I don't need to translate that. Okay, good. If in view and the distance less than that, then add the do that. Okay. So this is just going to accumulate the average position, because if each one turns out to be in view and the magnitude of the distance is less than 0.01, that's good. And then the velocity is going to be there, and then in. Okay. And so just as a little side note, I just want to put in a plug for length. I could have done that. You can do this. So I don't need the magnitude distance. I'm sure I could have easily, yeah, you can use that. Okay. Lesson learned. But I enjoyed making this function down here at the bottom. That was great. That was really great. These two functions. So I am working on really grinding through flocking, this flocking algorithm, and this is just the beginning. I'm probably going to be working on this for the better part of a few more hours, because I'm waiting to hear from a job, and I'm just sitting at home in front of the computer working on programming to accomplish this task of waiting. So anyways, all have a good day, everybody. Thanks for tuning in. Thanks for watching. Of course, I'm going to do more because I'm over caffeinated and highly excited to program. So.